Dobar dan. Good morning, everybody. I'm really happy to be here, and thank you for the invitation. You will allow me to take this off, because I'm not pretty with the mask. And I'm also honored for the invitation. First, because I'm honored to represent Apimondia, the Bee Health Commission. And second, because you are an amazing country, you are doing excellent things for the bees, and I really admire you. So I will take you through some of the challenges that we face for the health of the bees. Although, because there are so many problems and so many challenges, we don't have the time to give solutions here, but I will give you just a few hints. So for several years, we have this question: why we have elevated and increased colony losses year after year after year, and what it is that determines the health of the bees. As far as we understand the health of the bees, we play in two different levels. Because we talk about the health of the bees at the colony level, how the colonies are placed outside in the environment, the density of the colonies, how close they are together, and what is there for their food, and how is the environment structured. But of course, we also talk at the level of the individual bee. That means it's one bee, but it's the superorganism, so it's inside the colony. But this is the individual level. And when we measure diseases first inside the colony, at the individual level. And sometimes, the bee diseases, the symptoms may be hidden, and they are not obvious at the colony level, because especially when there are not many. So sometimes we are losing them. One colony could be sick, the other one it's not. And then at the colony level, we are losing the symptoms. If you look at this diagram that I borrowed from a French publication, you will see that there is, in fact, a very complex, and there are synergetic effects between the factors. And here you can see that at the corners, it's the parasites, it's the genetics of the bees, the pathogens, the habitat around of the colony, the weather, the food that they get, and that's also the nutrition, the invasive species, but also the beekeeping practice, what we do for the colonies. So I try to make groups of enemies of the bees. So which are the main enemies? And I think that number A, for example, here, according to my opinion, is the pesticides. Because with the pesticides and the use of general agrochemicals, we have direct effects, we have indirect effects, we have loss of biodiversity, and we also have loss of pollination services of the bees. And we crazy scientists find different ways of measuring this kind of effects, the problem and the effect. So you see different categories. We measure them in the laboratory, we measure them inside tunnels, so it's a kind of, we call it semi-field, in the field or in the natural condition. And we can find different tests for different problem or where the colonies are placed. And why I mention this? I mention this because the challenge that we have is first to transfer the results of the laboratory test to the field. Because sometimes we find different results in the laboratory, different results in the field. And when we want to convince the politicians or the companies that they produce the chemicals, that these chemicals are harmful, we have a big problem. Laboratory experiments are easy. The field experiments are very difficult to be performed. And the next challenge that we face is that there are tests, validated tests, that they are being accepted from the European Union for the acute and toxicity acute toxicity effects. Now we have for the chronic effects, but we don't really have tests for the sublethal effects, and this is the big problem. And when I'm saying sublethal, I mean when the bees do not die, you give them big dose, but they don't die, still we have problems with the heart, we have problems with the heart function, with the respiration. We have, for example, here you see on the left, you see the hypopharyngeal glands that they produce the royal jelly, then you see the heart, then you see a picture of the respiration, how they breathe. They don't breathe well. It's like they have a heart problem and a lungs problem. And then you see that they lose the ability to control the temperature in the brood. They cannot keep the temperature together, and also in the immune system. These are the sublethal effects. Okay. So we have to show that we do have problem while the bees don't die, right? So what we have to do is first to create more proof. Sometimes we need to convince not only the politicians, but some of our colleagues, some of the scientists as well. We need also to develop more and accurate tools, tests, to show them the effects. And of course, we need to convince the farmers. We need them as collaborators, so we need to convince the farmers to use less, or we also need to find alternative medicines, chemicals for the farmers. And all this just to reduce the losses at the colony level. And probably you are aware that in Apimondia since 2014, we have developed a survey that goes around. It's online all the time. Sometimes I remember to post it again. And this way you can register any toxicity events that you have from pesticides or, because I forgot to mention before, from veterinary medicines in this survey, because it's good to have proof. So I move to Group B. Group B are the pathogens and the pests that we face and we see every day in our colonies. And you can see there are a lot of hexagons there. So there are many. There are viruses, there are bacteria, there are microsporidia, there are a lot of families. However, we think that one of the most important ones and difficult to face and tackle and treat and get rid of is Varroa mite. And the question is, how easy is to treat Varroa when Varroa depends on the queen, of course, and the resistance of the colony to the chemicals, I will talk to you later, to the chemicals or the colony to Varroa itself, so there are two different things, but also there are other stressors as the Varroa is transferring viruses. So you have synergetic effects between all of them. So we know, and in every country, like in my country, I can't remember if I told you that I'm from Greece, a small country like yours, and we use quite a lot of acaricides, chemical acaricides. And I'm fighting for many, many years now, since 2005, to convince the beekeepers to use organic substances and not these chemicals one. Apistan, Perizine, Bivarol, Apiguar, Thimovar, Checkmate. So we have a problematic Varroa treatment. There are many, many problems, and you know probably all of them. Let's start for first, number one. Varroa is hidden in the brood. And with the global warming, we have brood even in areas during the winter, in areas that we used to have no brood at all. In my country now in the north, we have brood during the winter, so we cannot treat Varroa in the winter. There is resistance to acaricides. This is known for many years now. To many of the acaricides, Varroa has resistance, so we are not effective anymore. Varroa is transferring viruses. Varroa itself can cause a lot of damage in the colony, but most damages are with the viruses, not with Varroa alone. It's transferred from one colony to another colony. because bees are drifting, they change position, or because we transfer brood and we transfer frames with bees as well. So it's transferred between the colonies and between the apiaries as well. And as I said before, for the chemicals, the agrochemicals, the pesticides, there is also toxicity of the acaricides, and it has been shown for many of them, plus the synergetic effects. So one of the questions that we have to answer, or you have to answer as producers, is when is the good time or the perfect time to treat Varroa? And probably the answer will be different in each area and in each apiary. What you see here is the yellow curve shows how the population of the bees is increasing and decreasing during the year. And the red one is the increase of Varroa, if there is no chemical treatment, if there is no treatment. Sometimes Varroa is so high that it can go even above, even more than the population, like last year and this year in my country. So we think that we need to change a little bit the way we treat Varroa. For example, we should try to treat Varroa, not especially in the winter. This is something that we have to keep in our mind, but maybe just before it's increasing, so at the beginning of the summer. And before the colony starts going down, when the brood is more condensed, smaller, and then all Varroa goes into the brood, and you have the bees without wings then. Mm-hmm. Yes, this is something that we are thinking a lot, and we are working a lot in collaboration, many people in different countries in Europe, and I will show you later. And then the next question is when and how we have toxicity of the acaricides. Is there any toxicity or not? And it seems that there is toxicity of the acaricides, and I will show you only one result, which is a minor thing, but it's important. Because today you have a special event later on. You have an event for people that they suffer from diabetes. And this is a disease that shows that something in their body, in their metabolic rhythm and in metabolites and in metabolic enzymes does not work perfectly. That's why they have the disease. And if I want to simplify, very much simplify this and transfer it to the colonies, there is one enzyme that it's called glutathione transferase, doesn't matter how it's called, but this enzyme has different forms inside the body of the bees, and it's very important for them. And when we use different acaricides, almost all of them change the profile, the structure of the forms of this enzyme. So they change the metabolic rhythm and the metabolites, and then the balance is lost. The first one, the red, is the normal one, okay? And then the rest is what amitrage is doing, what Coumaphos with perizine is doing, what thymol is doing, bivarol, and a little bit what even oxalic acid can do, but maybe for a shorter period. So I go back to when is the best time to treat Varroa, and I will tell you that this collaboration between the countries and scientists in Europe lead us to this, what we call strategy to treat Varroa. And we are thinking that because it's good to treat Varroa before it gets too high, and this is during the summer, and almost everywhere during the summer we have brood. We have break now. So we have to break the brood. We have to make the colony stop laying, and that's why we cage the queens inside this cage, and after 24 days we treat with organic, like oxalic acid, organic substances. Maybe this is very difficult for people in my country to follow because we have too many professional beekeepers that they have more than 300 colonies. But for smaller scale beekeepers, it's easier. But of course, first you have to know your enemy. We say that it's good if you can, at least once a year, sometimes to follow to monitor the increase of Varroa, so you know where you are studying. Maybe your colonies don't need treatment, or they don't need succeeding one after the other, or following treatment. Anyway, this is one way to measure Varroa with icing sugar. You've seen that before. I'm sure you know how to do it. And what we also try to find in the laboratories nowadays, we try to see which populations there are resistant to Varroa, why Varroa is not reproduced well inside the colonies, and to breed from these colonies. And then if I move to nosema, for example, which is a problem, big problem, especially in countries with hot weather during a lot of months during the year, the problem is different then, because we have a depopulation of the colonies, and almost all of them. And no other symptoms. New nosema microsporidium does not give other symptoms apart from the depopulation of the colonies. And if you see in this diagram, shows that since 1999, so just before 2000, now it's 20 years later, that the nosema that we had, it was obvious in a few times per year or one time per year. Now it's all the year round. What we also know is we have synergetic effects. That means that there are other factors like the pesticides or other pathogens that you don't have 1 + 1 + 1 = 3, but you have 1 + 1 equals 3. And here you can see it's a publication from Belgium that shows that when you have more than 3 pathogens in the colony, your colonies are really going to be dead in a very short time. So if you have Varroa with the viruses, because it's very difficult to have them different, so you have Varroa, you have the viruses, and then if you have nosema or something else, even chalk brood, because kind of recommendations, I wouldn't like to give you recommendations, but it is something that we might discuss. For example, we can use some help additives in the food to help them, or fresh water, or your own pollen. Don't buy pollen from other people, and no antibiotics for nosema. And why we do not use antibiotics? Well, the main reason is because they are effective not on the spores, only on the next form, what we call vegetative form. The spores of nosema, also American fall brood, also chalk brood, they are very tolerant to almost everything, Yeah. The bee inside the gut has bacteria that they are what we call the useful bacteria. So the antibiotics, they kill also the useful bacteria that the bee needs. And when we use antibiotics, then we cover the natural resistance of the organism to the pathogens. It's something similar to what we do with our masks now. If we wear the mask 12 hours per day, at the end, we will get sick from a flu. And of course, the antibiotics stay inside the bee products for a long time. And it's not only because if we get honey, we eat so little and the antibiotic will be very little there. It's because we use the honey and the pollen and the propolis and the royal jelly for apitherapy, for medicines. So they have to be completely clear. And what we are going to do, for example, for American fall brood, okay, we can treat nosema somehow and keep strong colonies and in good condition with good nutrition. What we are doing for American fall brood, because in some areas in my country, it's a big problem. So it seems that in this case, we have to detect them early, very early, and of course then we have to burn the infected colonies. But personally, I'm very much into burning of the colonies and not use all the shock method to treat them personally. But this is personal. And I'm saying this to burn the frames because most of the times, or all the times, that when I see a colony who is diseased, it's sick from American fall brood, I see this picture or this picture. So that means that it's already gone to a very high stage of infestation. It's not only 1 or 2 cells in each frame. It's the whole colony is completely lost. So what I would like to tell you now is that you have to be very careful in the beginning of spring. First, when you are checking how the queen starts laying the brood, so you will see, even if there is 1 cell with openings in the brood, that's not good, and the whole frame has to go out. That's the first sign of American fowl brood. And then I would like you to remember that if you have a frame that is empty when you take it out from your fridge or wherever you keep your frames and it's empty, and you are not sure if it has American fowl brood, before you put it inside the colony, you will check in the way that I will show you now. Because usually we take a frame in the colony, has brood, doesn't have, doesn't matter. We take a frame and we look it like that, and then we turn it around, or however you turn it around, doesn't matter. But we always keep it upright, with the with the frame on top. But what I want you to do sometimes, try it, it's easy. You will hold the frame, you see it, but then I want you to bring it next to your chest and look, not this side, look this side from top down. And in this case, if there is no cells of brood like these ones, and they are only empty, the frame is empty, is the only way that you can see remains of the scales of American fowl brood in the frame. Because with the first sight, it's not easy to see, but then if you start see them, excuse me 1 moment, I will just go here. There are many more, but this, it's easy, much easier to see when you see it from top, bottom, okay? So, our challenges then, for the diseases in general, I think that it's to breed for resistance and to identify which of the local bees, because we are talking about genetics, which of the local bees are the best ones to carry on in the next generations. This is something that you can do it yourself up to 1 point, but then we can carry on in collaboration with the institutions that they are working on this and to identify through the most difficult and accurate methods. But for us as a scientist, it's also another challenge. Lately, we identified what we call health status index. I mean, it's just a number to show the health condition of a colony, just a number. We developed this idea in EFSA. EFSA is the European Food Safety Authority. And we think that if we find the variables that they can influence the health status of the colony early enough, we can predict what is going to happen and be preventive instead of treating a disease. Then we move to group C, which is another group. And here we are talking about the invasive species. It's not only the diseases and the pathogens and the pests that we have inside the colony already, but there are invasive species, and we mean the species that they come from an exotic country. Here you see the small hive beetle, Athena tumida. In Italy, it's not here, I'm sure. It's not here, it's not in my country. It's still only in Italy, but it's a big threat. And what is special for invasive species is that when they come, they are very destructive. They cause a lot of destruction, and then it's difficult if they are already established to get rid of them. And we think that the best solution for the time being, not to treat them, but this is only for Italy, but for us, is to have an accurate and as early as possible detection. So we have to be very careful of first what to import, if we import brood, if we import wax, if we import colonies, if we import queens. Early detection in the larva stage, and the same applies to the adults, because many times we find different things inside the colony. There are many, many small things, insects that they go in, they get something out of the pollen or the honey, but they are not this particular one. So we need a laboratory. And of course, the people that they have it, because it's not only in Italy, it's in Europe, but around the world, it's a big, there are many areas that they have it. Unfortunately, it's increasing. Then they have to find ways of keeping it in smaller quantities, because it's really very difficult to treat it with so many different types of traps. Okay. However, what I think that it's more dangerous for us and for you, for example, it's the invasion of the wasp, the Asian hornet, as we call it, the Vespa velutina, because it came in 2004 in France, somewhere near Bordeaux, and now you can see the green areas and the red areas, that the new ones where it spreads. It's not very big. In my country, we have Vespa orientalis, which is much bigger. This one is not very big, but it's very aggressive and does not allow the bees to go out of the colony. So the bees can stay there and even starve because they don't have any food. So we need to find ways of treating it or keep it out of our borders. How easy this is going to be, I'm not sure. Probably you have your own wasps or hornets here. How do you call them? Cerceni? Cerceni, because we use the same word, I recognize. We say cercenia, the big ones, in Greece as well. Yeah. Probably you have your own wasps. You have ways to deal with that. This is something different. It's more difficult. But just to be aware for the time being, we don't have to be afraid. Then we moved to another group of threats for the bees, for the health of the bees, which is the nutrition. Nutrition is very important because nutrition comes from the food, and the food comes not from what we feed in the colony. This is not nutrition. We feed only to keep them alive for a short period. Nutrition comes from the environment. And what it shows on this ellipses on your right is that you have different effects in the colony or in the bee when they are malnourished, when they are not well nourished. For example, you don't have pollen coming in, you don't have bee bread, you don't have well-fed nurse bees, you don't have well-fed queen, you don't have well-fed larvae. And you know very well, because you've seen it in your colonies, that when you don't have any pollen, the queen will stop. Maybe the queen does not completely stop, but they eat the eggs and the small larvae because they need the protein. This is exactly what we call cannibalism. They cannibalize, they eat the larvae. But also that means that the glands in the nurse bees that they produce the royal jelly are not developed well. That also means that the queen is not fed well and cannot lay as many eggs. And there is also other things like one enzyme, very important, that's called vitellogenin. Vitellogenin is very important for the development of the bees, and this goes so much down that really the colony cannot thrive, cannot be healthy or productive. And to connect this with the diseases, I'm just giving you two values that they show that when the bees are parasitized by Varroa, they have half of the vitellogenin of this enzyme of the healthy ones. And look here for the glands that they produce the royal jelly, the blue ones, the hypopharyngeal glands. On your left, you see round, it's like the grape, the pieces of the grape, and on your right, they're much smaller. And down, you see the fat body. What is the fat body? Okay, the right one, the picture of a healthy bee and a picture of a diseased bee. The fat body is very important for the bees. It's not because we want them to be fat and big, but because in this one, there are all these substances that they help the bees to detoxify and also to go through the winter. So if the bee starts from the summer, September. This is the months. Now is the period that the colony is producing the bees that they will help to overwinter. So if on September we have bees with a lot of Varroa because we didn't treat in July or August, and Varroa has already destroyed, plus the chemicals around, the fat body and the vitellozolin in the body of the bees, and we are waiting for the bees to not have any brood to treat Varroa, we are going to lose the colonies. And that's why I mentioned a few things that you might find difficult. I try to speak in a simple way with the enzymes and the fat body and things like that. Because when you treat for Varroa or for other diseases in your colony, you need to think a little bit globally, a little bit together in holistic approach. And I would like to thank you for your patience and your presence here. And I will leave you with this video that shows how precious and how sensitive is this small insect. And thank you for taking care of it. Thank you. Hvala.
Hvala. Thank you.